Okay, so I think that's quite a lot of time to wait. And a little disclaimer, I've been on, kids picking and dropping duty, so I wasn't able to finish the, additional R concepts chapter per se, but I thought it might still be reasonable for us to continue to meet. I will go through the sections that I've covered already. And I will probably, I was planning to go through the book chapter per se anyway. So what I'll do is I will talk through the things that I've completed reading and, give you the gist of it. And otherwise, for whatever section following that we can continue to work on, we will do that. But maybe I will do more of, reading through and discussing it. And I think sort of apologies for that. And it is very likely that my kids will still keep bumping in, but I guess we'll have to go with that. Before I begin, any any starting thoughts, any questions anybody has?
No, okay.
Okay. I'm quickly just checking what the next week's. Okay, so we have next week, Esmeralda, you doing descriptive stats, and then we have the next chapter covered. So I just need to send in a reminder for chapter 7 onwards again. Cool. So we're gonna talk about additional R concepts today. A lot of these things may not be some, very new for for most of us who, I know that, we do work in R, but there are, few quirks and few subtleties that sort of walking through or talking through them might be helpful, as it is, talked about in this section. So sometimes, there are these small little tidbits that we never thought about, and it always is there. We've seen it, but we've never given it a thought. So some of those things with handling packages and whatnot would come across, and let's talk through those things. So so this is a chapter which is sort of a follow-up from the previous chapter that I previously covered. And in fact, I think we still had a few sections pending, but I'll continue with this one for now. And then this section talks mainly about, or the intention behind this chapter is mainly to sort of give a little overview of things that will make our users' life easier as they proceed through next few chapters. So in chapter 3, we talked about, just getting acquainted with the R ecosystem. What is R? What are the features available in RStudio, and how to go about things. We talked about a little bit of data types. Then we will cover some, I think talked about the atomic ones earlier, and then we will talk about some others in this section. So some of sort of workflow things that the author says are sort of important to cover first before we start diving into things and before we start coding. So going through, section by section, before anything else, the author says that, it's important to understand what are comments. And it really, again, so if all of us have been coding in R, we know that it's the hash character, which is used for that allows you to write a comment, and it's also called comment character within our ecosystem. So you can, once you write hash, and anything that you write after that in that line of code is considered to be a comment, and the R knows that it not excuse me, it does not need to be evaluated, like a code needs to be evaluated. And most importantly, the purpose of using comments is to make it more readable in the sense, not the code per se, but the overall script, or letting future you or anybody else who's going to read this code, giving them a little bit of peace of your mind as to what you were thinking at the time what you were doing, writing the script, right? So in this case, for example, this example shows that how if this was written, you can just read it, but you don't exactly know what's going on, or at least why this was written this way. But when somebody writes it like this with commenting out each section or each bit of the information that that's going on in the head. It comes down here, so it sort of is relatively easier to read this, right? Although that's sort of, I think, my personal comment, and sort of having going through a lot of other codes, this is probably too much to as an example. I mean, this is just an example, but you potentially do not want to write comments like this for every line and so on and so forth. So when we talk about bigger scripts, it is more or less about finding that balance of not writing too many comments, or writing the code as readable as possible without having to write too much comments. So there is this as an experienced programmer, you want to develop that skill of writing the code itself in such a clear manner that your variable names, your function names are self-explanatory, so that there is lesser need of there's lesser need of the comments, or your comments can be shorter and things like that. So that's about that. So I think most importantly, so when we what is most important, I guess, in this section is that when you write a hash character and everything that follows it, so R knows that it has to ignore all of that piece of information. Next important thing that we want to understand or go through is the difference between installing and loading packages. Now, at the time this book was written, they've given the numbers that with the base R installation, you usually get like 30 packages being automatic installed within that package, and then there are about 5,000, but I think at standing today there are a lot more open source packages available. But so for anybody to be able to use these packages, which are part of the base function or others on CRAN, there are sort of two steps that you need to work on. There is going to be installation step, and then there's going to be loading step. And that only after that is when you can use a function in a given package, right? So installation is basically equivalent to saying something is available online. You need to install it, or you need to download it in your system, in your computer. That's literally what installation means. And then when you load a package, you're basically bringing it in the memory. So that's where these two things are different. And once it is loaded, so R knows now that you can use any function within this package. So I think, again, so sort of this whole summary of this paragraph is described here. A package must be installed before it can be loaded, and a package must be loaded before it can be used. So that two-step process I was talking about, with one exception I want to highlight, is that so once a package has been installed, right, and if there are situations where you basically probably don't want to use all the functions. So for example, if you know that you're not going to use a lot of functions from a given package that you are planning to use, right, you can use a namespace colon function. So what that does is it saves you the memory space. So when you load your when you load a new package in the memory, you're loading everything that comes with that package. So all the functions and everything is going to reside in your RAM in your R environment. But so for example, if lubridate is a huge package, now you know that in your entire code script you only want to use it once for some date function, right? So you don't necessarily have to load it in that case. If it has been installed once, what you can do is use lubridate colon as dot date, or whatever function that you're trying to use. That way you are not bringing the entire package in memory, only that particular function that you want to use. So again, there's this balance of when you would want to do this. So when there are barely any functions that you are going to use, that's a feasible approach to follow. But having said that, there is also, and I think that discussion comes in a little forward here. Yeah. So in here, what happens really is there are situations where you would encounter that one a function, like there's a common function name that exists between multiple packages. So they in this book they have talked about an example of what is it called, logit function or logit function that exists in package called char, which is something I forget this thing, but a CAR function, which is associated with some regression functionality. And then there's another function called psych, which is, which was developed by somebody in that psychological field and psychology field. And, it's meant for practitioners in that field. So both of those packages are very different. They do, all the different things, but there is this one function that's common in them. So now when you want to use a function like, when you're in a situation like this, R doesn't know which function you are aiming to use. So by default, what R does is it will take the function, when there's a common function name, it will use a function that was most recently loaded. Sorry, let me correct. So it will take the function from the package that was recently loaded. I don't know if I said the same thing earlier, but just to clarify. But if in case you want to use it from a different package, or in order to specify what's the correct package and the function that you are intending to use, then again, you could use the namespace approach that I talked about earlier, where you say, for example, char package. So you say CAR : logit function, and then go ahead and use it, give the arguments that you need to, right? So that's sort of one of the things that was brought up here in the discussion. Yeah, I think in this piece. All right, and before I move on, let me just cover up this one. So package panel in RStudio, we've talked about this one, but let's just quickly brush up. So this section, when you look at this, it has these checkboxes, it has these names and the descriptions, and there's no top level, sort of a title of this table. So I'll just review what this means. So when you click on this checkbox, that means you are trying to load this package. This description gives you, a bit of some top level summary of what this package is meant for. And these numbers, they indicate the version number of this package. There is this cross sign here, which allows you to uninstall the package from here. So please, and note that I said loading and by clicking. So, and if, or in this case, for example, here, if you have it checked and you uncheck it, so that is going to unload or, sort of detach that package. And then, this cross is going to uninstall it altogether. Although the book says, and, at that place where it mentions this detail, it says, that would be probably not something that you would ever do. However, I think I have done that myself in some rare occasions. So it's not like absolutely unlikely to use this sort of a feature, but it's there. You can always use it, maybe, but very only once in a while kind of situation. And now continuing to talk about loading and unloading. So this, this section, the following section here now talks about an example of foreign package, which is, one of those 30 packages that you get with our installation, right? But and the reason why we're talking about this is they're trying to show you the difference between installation and loading. So this package doesn't need to be installed because it comes with the our installation, but it needs to be loaded because it's not the default. So I think I missed one piece of information here. So up in the top, when they talked about the 30 and 5,000. Now, when R is installed, so in in the whole, maybe let's say setup of R, it has the 30 these base packages installed, but they're not all of them are loaded. So only 7 or 8 packages are actually loaded when you load, when you open up your R or RStudio. So these remaining ones you still need to load. And foreign is one of them. So if you wanted to, for example, read a SPSS file, you would use read.spss function from this package. And before you can do that, you would need to load this package. And how can you check if, whether that package has been installed or not? You could use the function name as a string parameter and pass it into the exists function. So here, as of now, it has not been loaded. So, and if you check this, you get a false here. So you can load it using library function, and you pass on the package name in as a string. So normally we tend to do this because it's straightforward. And then what this does is it defaults to where the R setup is, and there is a predefined location where all the installations should go. So that's where they would go. And then after you've done this library foreign, if you now check for any function that exists in that package, using exist function, it will return you true, meaning yes, now that function is in your environment. However, they have also mentioned the option of lib.loc, which is library location, which you can overwrite if you would like to. And that is if you want to change the place of where you are installing a library. So in that case, so if you want to override it, or so whatever the default location is, R knows where to pick it from. So then basically you don't need to tell that in the library loading where to load it from. But if you change that location, well, I would not want to, but if some people are in the admin, then probably they do. So then this is the option that you would want to use for doing that, for telling R to pick it up from another location which is not the default location. All right, so we've done the loading, and then if we want to unload a package, we could use, we could either uncheck from the right panel, or we could use a function called detach and say, which package I want to unload or detach. And then, there's this option called unload is equal to true. So now, just like when we install a few packages, there is, some messaging, being sent out on the console. Same happens with, when you detach it. So for example, in this case, it is giving a warning saying namespace cannot be unloaded, and namespace foreign is imported by Rio, and so on. So what this is really telling us is that, this package is also used by some other package. So there are dependency of this package on other packages that you've already installed. So it is not going to allow you to unload this in such a situation. But if these packages were not, not loaded, you will not see these concerns being raised here. So yeah, and I think again a little correction here. So it's a warning. So it's not an error. So it did the unloading, but it is reminding you that when you are working with Rio and Psych, and apparently you wanted to whatever dependency it has on the foreign package, if it gets to that, there might be some challenges or some errors that you might encounter. So it might be something important to keep in mind, that there was a dependency. So let's know that when you get to it, come back, you might have to load that. So because now that unloading is done, this again exists function for that function's name string would return you false. So that means it's done. And again, in the same sort of thought flow, so what this example talks about is, so we said there are dependencies, and in this case, it safely allowed unloading that package. But there are situations where one of the other packages that you already have installed on your computer is, for example, the matrix package. So some dependencies can be, I think, stricter than others. So in this case, for example, in the matrix package, this has a dependency. So when you install, or sorry, when you load this package, it has a dependency on other packages, and lattice package in this case. So it will automatically load that package as well. So I'm sure if you've done, loading of tidyverse or dplyr, you would see some messages, and those those dependencies will also be taken care of automatically. But in this particular case, right, when you detach the lattice package, it will error out saying the matrix package has been is loaded, so it may not make sense to unload this one at this moment. So R refuses to do that. So I think the difference being, if the dependency that you're trying to unload is actively being is an active dependency or not. I think that's how I would see it. I don't, I mean, this was not a word per se here, but this is sort of my understanding. So in the previous case that we were discussing, so we know in this case, it's likely that these packages Rio and Psych are the ones that you installed. They're in your system, like I said. So if they've been installed, they were used maybe prior, but in this session, they're not loaded. So if you unload this package, you get a message saying there is something else that depends on it, but it's only a warning because it's not loaded in the environment. In this case, when it is loaded, which has another package that has a dependency, it becomes a challenge. So it stops you from doing that unloading process. This portion I've talked about already. And I think I've talked quite a lot. So I'm going to stop for a minute and pause and see if there are questions. Esmeralda, any question?
Not so far, not so far. I am familiar with this.
Okay, so should I continue?
Not sure. I guess depends on you. I am familiar with the things have you been presented so far. So only if you want, only for the YouTube maybe, but yeah, I think let me check the rest of the chapter quickly.
Sure.
Or what do you think? Should we continue?
Oh, I am fine with continuing. Federica?
I cannot see the.
Yeah, okay. Yeah, so I'm familiar with those two things as well, but if you want to continue, but for me it's fine. Up to you.
I wasn't sure if I heard her correctly. Esmeralda, did you hear her?
I think she said yeah, that I can hear her like a little bit, like it's like a background noise, but I think she said she's also familiar with this, and it's okay to you to continue.
Okay.
Let me see. Where is the rest of the chapter? Yeah, I think I'm familiar with this, but yeah, it's if you wish to continue, it's fine. Maybe for the YouTube. Yeah, up to you.
Okay. Okay, I think I'll try and go faster than what I was doing right now, maybe then, just to sort of wrap up. Okay, so I've talked about that part. So now let's talk about managing the workspace. I think that very few things are here that when it comes to managing your workspace, it shows, and these are some of the things that we've already covered in the previous discussion. So you can see in the environment, you will see drop down here for the global environment. You would be able to see the values of, here you see values, which basically means all the variables that you are using, and which are atomic values. Then you can see the data frames, and You can see the functions, like so like the way you see values here, you could see data frames, you could see functions like that. This shows that you can, sort of change your view of how that looks like. This is really, just this view has the name and the value. This view has the name and some more information associated with it. And depending on what you're doing, kind of objects that you have, it may be useful to have that information as well. Now, a few quick things that we tend to sometimes might be helpful or come handy in certain times would be using a function called objects. If you write this on the console, you will see, the entire list of things that exist in your environment. And this function has a lot of fancy capabilities that glossing over in this example. Now, other than that, you could also use ls function. So basically, ls it comes from the shell scripting where it lists the objects. And I've not looked into the details of how these two are different, but both of these are options that practically will give you what exists. I think the difference could be in terms of just giving you the objects and then objects and the all the R objects versus only the variables and the function names and whatnot. Then one interesting thing that I have never known of and looks interesting here is a who function. So the LSR package, the package that accompanies this book, it includes its own function that you can use for this purpose. It's called who, which let's see. Get a fairly detailed books in the workspace. So who function basically comes from this package, and what this does is similar to what the objects and ls does, but with a little more information and in a more neater sense. So it is going to give you the name of the object, the class of that object, and the size of that particular object. Right. So yeah, I think this is interesting to, or at least a neater way to look at things. And then moving on, in order to remove the variables that you have in your workspace, and it's definitely needed sometimes to avoid any clashes of variables and situations like that. So you could use RM, short for remove function, and inside that you can just put the name of the object. You can do it for one or multiple separated by a comma, and that way you can remove your variables. So for example, in this case, if you did remove RM of seeker and lover objects and you did a who again, you will see that those two variables, they don't exist anymore. Moving on. Then we talked about navigating the workspace and the packages and all of those things. The next section talks about the file system. The file system itself. Give me 1 second. Okay, so I think I get it. So there are, when you're in RStudio, there are multiple ways of navigating through your file system. So one of the ways is to, directly look at, go to that in your Mac or Windows system, go to that physical file location and copy that location and use it to find the location of a particular file that you're interested in and open it or do whatever you need, load it or in your system and whatnot. The other option is to navigate it through your RStudio, that bottom right panel which says files. So you can click on, you can go up and down the folder locations and click through different folders to get to the file that you want to access. And then I think one of the things that they're talking about here is dot refers to, so if you're in your terminal, not console, but if you're in your terminal, your base location. So if you're using our project, the directory or the folder which where you have the R project would be your default for the terminal, but otherwise, it really depends on how it has been set up. So dot refers to your current working directory, and dot would refer to the directory above it. So when I think it's a choice of whether you want to use absolute path or you want to use relative paths. But talking about using our projects as part of your workflow, it makes it makes your code more portable if you use projects and if you use relative paths. With the requirement that you need to continue to you need that to maintain the consistency if the code has to move from one machine to another in that process, right? So these are just example of some absolute paths that are, for example, taken in this project, where you reference your data from. So in your terminal, right, you could use, or I think command prompt for Windows these are the ways you could refer to these libraries if C is your base location for current work, right? And then generally, in Mac, this tilde takes you back to your home directory, so your base directory per se. Now so one of the ways of working also, to work through your sort of modifying or getting to know your working directory. So where was I? Yeah, so you can use get WD to get your working directory and set WD to set working directory. But again, there is a talk by Jenny Bryan which says if you use set WD, I'm going to burn your computer. So it's not preferred way of working with your directory structure. So, and I think from that discussion that Jenny Bryan had done, it was probably at the time where she brought up this new package called here, right? So if you have to use relative paths, you can use here package and here function. I don't think it's been used it's been shown in this chapter, but that's sort of my go-to since I've learned about not using setwd. And the whole point of doing that is it allows you to use relative paths. And what that does to your code is that it makes it more portable and reliable to use on other locations. So most importantly, if you've noticed, if you are using a Mac versus Linux versus a Windows system, the dashes that are used, they would be different. So in some case, in one of these cases, it'll be a / and in other, it'll be a /. So to avoid all of those confusion and having to manually change that, if you use a here package and here function or here : here, you can just say in quotes user comma in quotes Dan, and then that basically tells you that go make the file structure yourself. These are the folders that these are the folder this is the folder structure that I'm following, and this is my file name at the end of it. So that's sort of very useful way to make things portable and make your own life very easy. You could use list.files function similar to objects, which applies for objects. This is for all the files that you have in your current directory that you are in, and it will show you all the R data files and whatnot that exists. I've not used this path.expand function, but so I think what this is telling you is sort of like get WD, but in a different way. So you can change the user directory if you want. So what is the root is what it is going to tell you. So so when I use our projects, when I click on the 3 dots on the right hand side in the file section, putting this tilde brings me back to the project directory that that's where my .rproj file exists. And although in that same location, clicking on that R blue sort of cuboid thing also brings me back to the same location. But it's good to know. Why do Windows path use wrong slashes? I am not sure. I've not read this section. So through the files panel, I think this is what I was talking about earlier. So this screenshot shows you this 3 dots, which is what I was saying, that you can click and then you can navigate to any location that you would want to. It doesn't necessarily, you don't necessarily have to navigate or browse through the structure in a sequential manner. You can go through and maybe copy it from your Explorer and put that location into, when you click on the 3 dots directly, it'll directly jump to that location, which can be useful in many cases. But you can keep on clicking through this home, our book and data, and back and forth in whichever way you would want to access your data or other files. If you are in an R project, you would also see a blue cuboid thing, cuboid thing here with, and there is R written on that. So if you click on that, that's where your default R project directory will get to. Similar equivalent to which is, if you click on this and you type tilde and press enter, that's also the same location that it will take you to. All right, so I think that's quite a lot. I don't think I'll be able to cover everything. So loading workspaces files using R. So yeah, so there are situations where you would want to you're working with lots of data and you've loaded them once and you want to reuse that. You could simply save them as a R data file and then come back to it using a load function. You can absolutely just load that R data file and it'll everything that all the objects that were there that were saved in that R data R data object would now be loaded and will show up in your environments pane. Again, here it allows you to use either the absolute path, like in this case, or use relative paths like so. So loading the workspace from your workspace files using RStudio. So I think what that means is you go to the file section, locate the R data file which you are interested in, click on it, that file name, it'll show you a pop-up saying, do you want to load this file? You click yes, and then this is exact same code will run in your console sort of as a result of that clicking. So a point and click option for that. And I think I would probably just skip these things because these are all loading, importing data options that we've looked at. I'm sure we've all looked at. If to read CSV files, you could use a read.csv or read_CSV functions in dplyr. Importing can also be done from your RStudio panel itself. Import data option, I think that's called. It will show you a little preview. You can go ahead and import. It does allow you to make some changes. And then saving a workspace file using save. So earlier we talked about loading an R data file. I guess this probably should have come sooner, but so when you're at a point where you've ensured that these are the files that I need to save because I want to come back to this tomorrow, but maybe, for example, let's say I need to restart my system or anything, I need to shut down, or it could be anything else. So you can do that by making sure your current state, so whatever you want in your environment to be reloaded next time, and you have nothing more, nothing less, you're ready. So you say save.image file is equal to the name of file that you would want, and .r data extension is what you would want to give. You can always check with who function from LSR package, and it gives you all the details. That's about that. Saving a workspace. I guess there is an option to do that using point click option 2, save workspace as, from the top of, I think, tools options. Session, save workspace as. Other things that you might want to save, outputs and scripts. All right, so I think for now, I'm gonna pause here. Folks, anything else? Any questions, any points?
Not really. On this side.
Okay. All right, so I think so we are, I think, good to pause sort of the discussion here, and I think there are some interesting things to talk about when it comes to factors and lists, at least. So I think what we can do is continue to go through the following chapters, but when we have weeks, if in case we end up having weeks where we don't have any other presenter, I will come back to this chapter and go through these sort of these missing sections that I've not been able to cover so far, because I think I've seen that factors is a very special data type, and there are some nuances to it, so it might be really useful to discover those and maybe talk about use cases where you use them and where you have failed at them, because that's what it makes it special.
Or I don't know. Do you want to extend until factors, or maybe take a time from the next session? I could, like, I don't know, present after you in the next week.
Yeah, I can, but I know I know when we started, you two were like not too sure if you want to continue talking about R, because you both are pretty comfortable with it. So I wasn't sure if I should take up your time. So anything is fine for me. So
Okay.
what we can do is maybe let you have the discussion of chapter 5, because that also has a lot to cover. If you finish in time, then I'll come back to this. If not, we'll probably take up another day, because we still have like half of this chapter left.
Bianca.
Yeah, Priyanka.
Hi, sorry, I had my microphone very low, so the volume was very low, so that's why so you couldn't hear me. But I was looking at the Google Sheet. Okay, there's a chapter which is chapter 8, basic programming. Okay. And it's going to be in 1, 2, 3, 4 weeks, more or less. Okay.
Yeah.
You can make it or not. But I was thinking, as this second part of the 4th chapter, okay, is about where is it? So basically factors, data frames, so that generic functions, so things that you use with programming more than just like basic moving files or saving files, reading, and yeah. So we might want to, I don't know if you agree with that, go forward with the chapters, and then when we are within 4 weeks, just I don't think it takes much longer to do this remaining paragraphs.
I think that makes sense.
Yeah, right before chapter 8, which is basic programming, we can introduce these generic functions, the formula, those things there, basically.
Yeah. Okay, we can do that. Yeah. I think that's a good that's a perfect idea, I think. So that way we don't disrupt the flow of all the already signups that have been made. And then since we already, it's already given, so someone is going to cover this chapter, so I can talk in that week and finish off these topics.
Yeah, I think it's yeah.
No, it's fine.
Yeah. No, I mean, so we go forward, because otherwise, next week is Esmeralda. Is that right? Yeah.
Yes.
And the following week, I see Eric. Is he about to take the chapter for real, or?
I will check with him. So he did posts. I think a few weeks back he had taken up that section. I will ping him on Slack and check if he is going to definitely make it. But otherwise, I will update that and I'll send a message accordingly.
Okay.
Yeah, I like it. Sounds good.
Yeah. Okay. Cool. All right. So thank you, everyone. Thank you for your time. Thank you for making it. And we definitely will meet next week, same time. But until then, we will catch you on the Slack.
Okay.
Yeah.
Thank you, Priyanka,
Thank you.
for presenting.
Thanks, everyone. Bye-bye. Bye.